Welcome back to part 25 of the Introduction to Insect Morphology and Anatomy. Today we're going to start talking about the reproductive system of insects. I've saved this towards the end because it is an extremely complicated set of systems, both internally and externally, and is also highly variable between insect species, not to mention in between like entire orders of insects. External and internal genitalia can frequently be used to do identifications on insects. And so it is something that you need to know about, even if you are, you're not going to, you don't, you're not super interested in morphology or anything. If you do want to be able to do even basic species ID, you do need to be able to recognize all of the structures of the internal and external reproductive anatomy, just because it is so frequently used for species ID. It is frequently the only difference between very closely related species, the structures of the genital plates and things like that. So I figured I would save this for last because it is a very complicated subject. I'm going to divide it into multiple sections for both internal and external anatomy. Part of the reason also is it's hard to come across good pictures that represent all of the various parts because there's so much variability between insect species. But today we're going to talk about the internal reproductive system of female insects, and we're going to use the queen bee as the example. So interestingly, even though the majority of the insects in a beehive are female, the queen is the only one with the completely developed reproductive system. The workers are all female, but their reproductive system is suppressed, and so they don't really grow into maturity. It's pretty much only used for the production of venom. So, but in the insect, or in the female queen, the female reproductive system is very, very large. It's extremely well developed because she is responsible for the production of all of the eggs for the colony. So her reproductive system is a good example to use. This particular drawing comes from R.E. Snodgrass's book, The Anatomy of a Honeybee. And it is a very old book. I think it was published in 1910. But it is still considered kind of the go-to book if you want to understand the morphology and anatomy of honeybees. It's extremely well done. He did all of his own drawings and they're amazing. So I've taken that drawing I've taken the drawing out of that book and I've added new tags for everything so we can start discussing it. So this whole system, this is the female reproductive system, and we will zoom in here in just a second, but this will be the posterior, and up here is the anterior, right? So the butt end is down here, and this system takes up an enormous amount of space in the bee's abdomen. So in the queen honeybee, she has a pair of enormous ovaries, pear-shaped ovaries, that take up a ton of space. And this is responsible for her being able to lay up to 3,000 eggs a day. So an enormous amount of eggs come out of this, and a queen can live for years and years and years. And it's something like 200,000 eggs a year are laid on average by a queen bee. But an ovary itself, so the ovary itself is just one side of this. So, these are two different ovaries here. So this is divided to the left and right ovary. And they are not connected, so they are free within the hemicele. But an ovary itself is made up of a number of strands called ovarioles. And ovarioles are these kind of chains of beads that you see progressing up, and they get smaller and smaller and smaller until you get to the tip of the ovary. And these ovarioles are where the eggs are and where they develop. So in the queen bee, the eggs develop over time. They start as an oocyte, just the most basic reproductive cell for the female. And as they progress down the chain, they get more mature. They go through a maturation process until they get to the very bottom here, where it is a fully formed ovum, and the shell or the chorion is added. The development of the egg is very complicated. I won't be getting into it in this series. That's more something for a physiology series. But not all insects are born with this, or not born. Not all insects mature into the adult stage from the pupal stage or the last nymphal instar stage with this kind of setup of the ovary. Some females have this setup where it starts as an oocyte and they are produced over the life of the adult insect into mature eggs. And others are born, or not born, but mature with a full complement of eggs. They emerge from their pupal case or from their last nymphal instar with a full complement of completely mature eggs. Frequently that is called, we refer to that state as being a gravid female. And if you were to dissect them, you would find that their abdomen was full of very large, very mature eggs. But the adult queen is not gravid in that sense, but because she lives for a very long time, she needs to be able to continuously produce eggs, so the eggs are kind of matured as needed. So the ovum is finally developed at the bottom of the ovary here, where it passes into the oviducts. So these two branches here are the lateral oviducts, and they meet together into the middle in the common oviduct, or the shared oviduct. And the ovum passes down out of the ovaries through these oviducts into this shared oviduct. Below that, you have what is kind of the mating chamber called the bursa copulatrix, and that is kind of this whole chamber down here, this whole bell-shaped chamber. And attached to it is a gland, a very large gland, called the spermatheca. And the spermatheca is where female insects can store the sperm that they receive from the male when they mate. And particularly with the queen bee, she will only mate for one interval in her whole life. She'll fly out of her colony when she's a virgin queen, and over the course of several days she will mate with hundreds of drones up in the air, and all of that sperm is stored in the spermatheca for the rest of her life. And she will keep that sperm alive through the spermathecal gland, which kind of overlays the spermatheca, and this secretes nutrients and water and things into the spermatheca to keep all of the sperm alive. As the ovum passes down into this bursa copulatrix, which is made up of a series of glands and pouches, into this bell-shaped mating chamber, it is fertilized with a sperm from the spermatheca, and this is a controlled process of the queen bee is only allowing one sperm at a time out of the spermatheca to fertilize the eggs, and then the ovum passes down. For most insects, this is where this bursa copulatrix would be attached to an ovipositor. But in the honeybees, the ovipositor is modified into a stinger. And this is used for the delivery of venom. But the egg comes out, I believe, next to the stinger. But the stinger itself, this modified ovipositor, is attached to a series of accessory glands and the venom sac. So all honeybee females have this venom sac. In workers, this is the most well-developed portion of the reproductive system. This is where the venom is stored, the poison is stored, and it is produced through a series of glands. It's a complicated toxin produced through a series of glands. That's what all this snaking nonsense is. Those are all the accessory glands attached to the venom sac, and they are producing the venom. So that is stored in there. The queen does have a venom sac because she does use it, not so much for self-defense, but to kill rival queens when they are developed within the colony. There's a fight to the death, and one queen will kill the other using her stinger and her venom. So there is a reason for the queen to have that, even though once she's back in the colony from all of her mating. She never leaves again. So this is the extremely complicated honeybee system, a honeybee female reproductive system, not counting the external valvifer plates and things like that. Generally, with most more primitive insects, it's not this complicated. The honeybee is a relatively advanced, highly evolved insect with a lot of more primitive insects like silverfish and stuff. They won't have this spermathecal sac here or the spermathecal glands. The bursocopulatrix will be much smaller. They won't have any of this poison sac, although they will sometimes have accessory glands that attach directly to the bursocopulatrix, and they're used for the production of other chemicals. So there's usually less going on. Generally with the honeybee, there's quite a bit. So if you can understand what's going on here, you can probably figure out what's going on with the other insects. So next time we will talk about the male reproductive system, internal, and then we'll switch to the external reproductive systems of both male and female. And I'll see you guys later.